Okay, so this is physics 4.3 to 4 point whatever, I think 4.5 course division. An ideal tops excluded. No, we're not gonna do tops. An ideal transformer is connected to a 240 volts 50 hertz supply. The primary winding has 4,800 turns and the secondary windings have 2,000 turns. Why is an AC supply used? If you're using a transformer, can you use DC? No. Remember, the operation of transformers requires AC to produce an alternating magnetic field, hence a continuously changing flux needed to induce an alternating EMF. Remember, this was actually a CA question. Okay, transformers requires alternating current to produce an alternating magnetic field needed to induce an alternating EMF. This was a 3 blank question. I remember it. Okay. Part B. Why is the core joining the primary and secondary made out of iron? Why, guys? Because iron is ferromagnetic, so it ensures good magnetic linkage between the primary and secondary coils. This came, by the way, in the mini mock. I remember, and I saw it in a past paper question. Okay, why is it made out of iron? Because iron is ferromagnetic. Forget about ferromagnetic. Just say iron ensures good magnetic linkage between the primary and secondary coils. Okay, because remember, انت عندك البوكس وعندك الكويل هيك. We have the secondary coil هيك. Okay, and you need to basically send the electricity to there, right? You need a material that can send it properly. Okay, since now we're working, how does it work? The alternating current produces the alternating magnetic field, right? So what causes this sending is the magnetic field. So you need a material that's magnetic. That's why we use iron. Okay, because it ensures good magnetic linkage from the first coil to the second coil, or primary coil to the secondary coil. Calculate the output voltage from the transformer. Remember, the formula is VO over VI equals NS over NP. Considering this is what the transformation ratio, if they asked it, right? V out over Vn, we don't know, we're trying to calculate the output. V out over Vn is 240, is equal to NS, the secondary winding is 2000, NP is 4800. Let's just do this on your calculator. You should get 2800 divided by 2000 over 100. You should get 100 if the calculations in the solution are correct. What is the output frequency? Frequency, does it change in a transformer, guys? No. Okay, فالفrequency بتضلها شو 50 hertz. Okay, it stays the same. Okay, in any transformer. An ideal, I'm going a bit fast because at this stage, February 21st, you guys should know this. خلاص, we've done so many CEs on this topic. We did maybe one periodic حتى. Okay. An ideal transformer is connected to a 120 volt AC supply. The primary coil has 960 turns. Calculate the number of turns in the secondary coil needed to produce an output of 6 volts. We're still on the same formula, huh? V out over Vn is equal to Ns over Np. Okay, what's V out? V out, they said 6. N is 120. With the primary coil, and we want the secondary coil. We're trying to find the NS, but they gave us the primary coil is 960 turns. Okay, cross, you should get how much? I don't know. 6 over 120 times 960. Yeah, 488. What kind of transformer is this one, guys? If without looking at part A, if the voltage is decreasing, then akid, is it step down or step up? Akid step down, right? What is meant by describing a transformer as ideal? That means no energy is lost. So the power in is equal to the power out. Okay, no energy dissipation. This is the main keyword. Okay, perfect magnetic linking and no energy dissipation. But obviously that doesn't exist on Earth. But anyways, we just idealize transformers for easier questions. And no. Anyways, for practical reasons, we always say it's ideal. Anyways, whatever. A transformer is used to operate at a normal brightness. A 12 volt 48 watt lamp from a 240 volt supply. Calculate the current taken by the lamp. Okay, they're saying it's ideal. They didn't say it's ideal, but I think since they're talking about part A being ideal, for here it's ideal. What's ideal? What does ideal mean? Means P in is equal to P out. What's P equal to? IV. So I in V in is equal to I out V out. Let's do it. I in V in is 48 times 12 equal to I out, we don't know it, times 240. Let's see, what's the solution? What? Ah, yeah, I'm stupid, guys. Sorry, huh? I thought this was amperes, but it's watts. So they gave us the voltage. Shit. They gave us the voltage and they gave us the power. How do you find the current? By the lamp. Yani if it gave us the voltage and they gave us the power. P is equal to IV. Okay. P equals IV. So what do? 48 is equal to I times 12. So that means I is equal to 4. Yeah, pretty easy. Okay. The current in the primary of the transformer. Okay. So we found the current taken by the lamp. Okay. How much is the current in the transformer? This one should be a decimal, I think. Yeah, it should be a decimal. Yeah. We found the current taken by the lamp. It's I equals 4. You can do P. Hella, you have to do P in is equal to P out. Okay. P in is what? 48 watts. Or you can do IV. Adi, whatever you prefer. P out, we don't know, but we know that P out is equal to IV. Right, so 48 is equal to the voltage. We know it is 240 times the current we're trying to find it in the coil. Okay, so you're gonna get 48 divided by 240, which is 0.2. Describe the working principle of a transformer and why is a laminated core used. What is the working? How does it work? You know that alternating current produces a variable magnetic field. This came in the CA. The magnetic field is led by the ferromagnetic path, soft iron core. Why is it used? Okay, yeah. Where am I? Yeah. The magnetic field is led by the ferromagnetic path. No, in other words, what do we call it? The soft iron core. Forget about this. Okay, forget about this. What's it covered with? The soft iron core. We know this. From inside the primary coil to the secondary coil. This is all common sense. Primary coil to secondary coil. How does it work? Alternating current produces variable magnetic field that produces a variable EMF. Induced EMF, variable induced EMF. Okay, anyways, with only a small decrease in strength. Okay, the variable magnetic field in the secondary coil induces an alternating current in the secondary coil of the same frequency as one in the primary coil. A laminated core is used what? In order to have less energy loss by eddy currents in the core. Okay, look here. You have the soft iron core is used for what? It's used so because it's a good magnetic material, it allows for the variable magnetic field to be moved from the primary coil to the secondary coil. Okay, so why is it laminated? It's laminated because of the eddy currents. You guys know eddy currents are these like spikes in current that we don't like to see them, but it's laminated to prevent these eddy currents from causing very big energy losses. Okay, so that's why it's covered and laminated. Okay, so if they asked why is it laminated, say because to reduce the energy loss by eddy currents. I've never seen them ask it. An ideal transformer is connected to a 240 volt 50 hertz power supply. The primary windings have 4,800 turns and the secondary windings have 2,000 turns. What's the difference between a step-up transformer and a step-down transformer? Okay, the step-up transformer increases the induced EMF voltage, right? Where the secondary coil has more. But a step-down is used to decrease the output voltage. In this case, the secondary coil has less turns, blah, 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 blah. Pause and read if you want. So akid, for step up, the transformation ratio is greater than 1, but for step down, the transformation ratio is less than 1. Calculate the output voltage from the transformer. Okay, V out over V in is equal to NS over NP. So V out is how much? We don't know, we're trying to find it. Over V in 240 is equal to NS, secondary winding 2000, will primary 4800. You should calculate it, you get 100. 21. The input power is 2000 watts. The transformer delivers 1500. What is the efficiency? Efficiency is what? P out over P in times 100. It looks like this or something. I don't know what the symbol is. Efficiency is 75%. Okay. A step-down transformer is connected to a 240 volts power supply. The required output voltage is 12 volts. The efficiency is 95%. If the number of turns in the secondary coil is 100, then what is the number of turns in the primary coil? Some people here, they're gonna do 95% of 240 and then do something. No. خلاص عادي. Turns. We never said anything about efficiency and the voltages. Okay. فأنت just continue normally. What do we do here? V out over V in is equal to NS over NP. Type, what's V out? The required output is 12 volts. The input is 240. NS, the secondary coil, it's 100. But the primary we don't know. فwe're gonna, and NP we don't know it. To find NP, it's just 2000. Okay. Type, if the current in the primary coil is 3 amperes, what is the power in the primary coil? Type, let's take a look. How do you find power? Power is equal to IV. Do we know how much the voltage is in the primary coil? Yes, 240. For 240 times 3, which should be 720, huh? Yeah, 720 volts. Watts, huh? Not volts. What is the power in the secondary coil? Type, the power in the secondary coil, this is when you include your efficiency. Efficiency only comes when you're talking about power. Okay? If it's 95% efficiency, وانت you had 720 watts in the primary coil. طيب okay, انت هلا in the secondary coil you're 95% efficient. Are you gonna have 720 watts as well? No. We're gonna have 95% of 720 watts. Right? You do 0.95 times 720. You get 684. There you go. Question 23. Okay, hello, we're on 4.4, the power station stuff. Okay, these are very easy, صراحة. Okay, not much left. Okay, what are the advantages of transmitting power at very high voltages and using alternating voltages? This comes in the CA, by the way. It came like this, the grid. Okay, what are the advantages? Let's take a look. Okay, if you're transferring at high voltages, it's gonna reduce power loss, right? Okay, and using alternating voltages, because transformers can be used to manipulate voltages. So that's why when we transmit power, we use a very high alternating voltage. Okay, because when you're at a high voltage, less loss. Okay, and when you're at an alternating, you can transform it and manipulate it. Right? Can we use transformers if it's not alternating? No, right? ممنوع. A 6 volt 24 watt lamp, so هعطوك الفولتج هعطوك الباور, shines at full brightness when it is connected to the output of a mains transformer as shown in the diagram below. طبعا هي okay, shines at full brightness. Assuming the transformer is 100% efficient, calculate the number of turns in the secondary coil if the lamp is to work at its normal brightness. Let's see here. The secondary coil is what gives the power to the energy to the lamp here. Okay, so let's see the number of turns in the secondary coil. What do we know here? They didn't tell you the turns in the primary coil. So can you solve without it? No, you can't. Keep looking, and it's actually hidden right here. 800 turns. Okay, look at your diagram. Now, of course, we can solve easily. We have V out, we have V in. Can we do it? Of course. Yeah. NS over NP. So V out at day 6, V in at day 240. NS at day, we don't know what we're trying to find the number of turns in the secondary coil. El primary at day 800. صح? You should get 800 times 6 divided by 2. 6 over 240 times 800. Yeah, 20 turns. طيب. They want us to calculate the current which flows in the main cables. طيب, مش P is equal to IV, right? طيب, okay, we have the power, we have the voltage. It's going to be 24 is equal to 6I divided by 6. You're going to get I is equal to, wait. They said main cable. Yeah, bro. My fault. Okay, main cable is he, because I looked at the answers. I was, why is it such a small number? Okay, yeah, main cable is يعني here, huh? Okay, that means we have to apply P equals IV, but over here. Okay, we know that since the transformer is 100% efficient, معناتها the power here is the same as the power here. Okay, so it's 24 watts over here. Okay, هلا apply 24 is equal to I times V, which is 240 in the main cable. Divide, you're gonna get I is equal to 0.1 ampere. Okay, very simple. طيب. Explain whether and how the number of secondary turns of a transformer should be altered. If two 6 volt lamps in series are to work at a normal brightness. So, إذا you want to double them, you want to have now 2 lamps, and you want to double the amount of voltage reaching it, right? So what do you want to do if you want to double the amount of voltage? What do you do? Double the secondary turns, right? The number of secondary turns. 2 6 volt lamps in parallel are to work at normal brightness. Oh, wait, hold up. Now, what do we know about series and parallel. In series, we know that the voltage actually adds up. That's why you have to double the NS. But if it's in parallel, what do we know about voltages in parallel? We know that no matter what the voltage is, the lamp on top is gonna have the same voltage as the one down here, right? Remember, voltage is the same in parallel circuits, right? Will you have to manipulate the number of secondary turns? No, stays the same. خلاص عادي because it's in parallel. Okay, but let's take a look at the answer. Okay, so the number of turns would have to be doubled for the series one. Okay, in parallel voltage is the same, hence V out remains as 6 volts. The number of turns in this case should not be altered. Okay, very easy. Question 24. What's the advantage of power transmission at high voltage? It reduces power loss. صح? Reduce the power loss. Natural transmitted current will be reduced, which in turn reduces power loss. Explain how to set an appropriate fuse or circuit breaker. CB stands for circuit breaker. Okay, these are very boring. You need to read. Okay, sorry. I apologize, but you're gonna have to read. First, read the power requirement. Okay, and how do we attach a fuse or circuit breaker? We need to attach it based off of the thing we're attaching it to, right? So, if you have a 5 watt, lamp, you can't attach a 50 watt circuit breaker, no, and you can't attach a 4 watt circuit breaker either. You need to add something that's appropriate. So let's see. First, read the power requirement of the appliance from its specification plate. Then use P equals IV to calculate the current requirement. Finally, select the fuse from the values available commercially so that the current at which it blows is the closest value to I but greater than it. So, let's say مثلا it's a lamp running at 24 watts, 6 volts, okay, and we want to find a fuse for it. What do we do? What fuse do you use? Okay, our fuse is measured in amperes, okay? It detects current, remember? Type, what's the current here? Using P equals IV, you're going to 24 divided by 6, so 4 amperes. Does that mean I use a 4 ampere fuse? No. Okay, does that mean I use a 10 ampere fuse? No. What do I use? I use a 5 ampere fuse, 4.5 ampere fuse. You need to allow that small space for some eddy currents that may slide, okay? So that's how you select your fuse and circuit breaker. Many modern low current appliances are sold with only 2-pin plugs and no earth connection. Why is that? This applies to appliances that have a tough plastic chassis instead of a metal one and no metal parts protruding from the inside of plastic. This is boring stuff, okay? You would never see this in an exam, okay? How should a transformer be fused? Earth. Okay, but you should know this in case you see it in multiple choice. If you see, the 2-pin conductors, 2-pin connectors, okay, the ones in UK and Europe. If you when you go to your own country, I don't know. I know when I go to Lebanon, I can't use the same charger I use here in the UAE because there it's a 2-pin connector. I need what's it called, the transformer. Anyways, the reason why it's a 2-pin connector there is because the appliances there have tough chassis instead of a metal one. It doesn't require an earth. Remember, the earth one is just take to prevent electrocution, okay, and also it's because no metal parts protruding from the inside of the plastic chassis to the outside. Well, too much up. Okay, how should a transformer be fused or earthed? Okay, a transformer should be switched and fused at the live wire of the primary coil. It should also be earthed. The earth wire should be connected to the core of the transformer and to the outer chassis. Okay, نحن remember we agreed that we need to earth the transformer. Why? Because إذا you went and touched it, so you don't get electrocuted. Okay, so that's why the earth wire should be connected to the core and to the outer chassis. Okay, so you have the core. If you touch the core and the earth wire is damaged, you're gonna get electrocuted. Okay, that's why sometimes when the earth wire is damaged, sometimes you might feel electrocution when you touch one of your appliances at home. Let it be a washing machine or iron or maybe kettle or your gas stove. It happens for me, the electric stove. It's probably because the earth wire is broken. Okay, you call your electrician, and he will come and fix your earth wire. How does it work? The earth wire is connected to the core, the metal core, okay, and to the outer chassis. وخلاص, it earths it and goes outside, so lets the charges leak outside. Okay. List 3 do's and don'ts with electricity Okay, you can read this. Do switch off when you're not using them. Do replace the fuse with the correct rating wire, never with an ordinary wire. Learn how to connect plugs correctly. Do not expose wiring unless it is disconnected. Do not take high rated power appliances like hair dryers into wet areas like bathrooms because the risk of getting an electric shock is high. Do not use plugs which are damaged and have no cable grip. La la la. Okay, that's a lot of بس حكي على الفاضي. That's what we say in my country. طيب 29 and 30 وخلص we're done. Discuss the working principle of fuses. How do fuses work? Remember نحن fuses they melt when the current is too high, right? So fuses are wires of higher resistance than the wires they protect, and preferably a lower melting point that connected in series when the circuit they are supposed to protect. If the current suddenly rises, what's going to happen? Since they have so much resistors, and since their melting point is so low, what happens? Enough heat will be produced in the fuse to melt the fuse, thus breaking the circuit. Fuses must always be placed on the live wire. I think this came before, or I saw a question that looks like this. Where should fuses and circuit breakers be placed? أكيد on the live wire, huh? Never on the earth wire, because the earth wire doesn't have any electricity. How will it detect? Question 30. Which fuse should be used to protect a hairdryer that operates normally at 1.5 amperes? Obviously, something like 2 amperes. You can't use lower because it will break before you even turn on the hairdryer. Or you can't use one that's way higher because it won't detect overcurrent at all. Okay? هيك بنكون خلصنا chapter 4. Thank you so much for watching and good luck in your exam.